Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss integrals. In the previous class, we have discussed the concepts of exercise 7.9, that is definite integral of a given function. By using several methods of integration, we found definite integral of a given function. I hope you have learnt well. I hope you understood well. Haven't you, my dear children? Right. Now come to the concepts of exercise 7.10. Are you ready to listen the class? Right. In the previous sections, we have discussed several methods of finding the indefinite integral. Okay, my dear children. One of the important methods for finding the indefinite integral is the method of substitution. You know, method of substitution is also one of the methods to evaluate indefinite integral. We use the same concept here also. Okay, my children. Evaluation of definite integral by substitution. How can you find definite integral of a given function? See the steps. We follow these steps to evaluate integral a to b f of x dx by substitution method. The steps could be as follows. Okay, my children. First step, consider the integral without limits and substitute y is equal to f of x or x is equal to g of y to reduce the given integral to a known form. As we followed to evaluate integral by substitution method, here also we follow the same steps. Nothing difference, nothing special. Okay, my children. Step 2, integrate the new integrand. Okay, my children. With respect to new variable without mentioning the constant of integration, because we are finding definite integral. So we ignored to write constant of integration after finding the integral of a given function by substitution method. At the final step, actually we write constant of integration. We add constant of integration in the case of indefinite integral, but here we are finding definite integral. That is why we ignore to write constant of integration after finding the integral of a given function by substitution method. Okay, my dear children, understood this step. Step 3, resubstitute for the new variable and write the answer in terms of the original variable. Again, after the last step, after getting the integral, we had to resubstitute. Again, we had to change the given function, change the last step into the original variable. We have done that part also. Previously, we have done that part also. Haven't you, my dear children? Right. Now, fourth step, see, find the values of answers obtained in the step 3 and the given limits of integral, and find the difference of the values at the upper and lower limits. After finding the integral of the given function by substitution method, finally we write the answer in terms of the original variable. After writing the answer in the original variable, we substitute upper limit minus lower limit. Okay, my dear, this is the one method for to evaluate a definite integral by substitution method. Okay, my dear children, there is another method to simplify this method. There is another method. I will tell you in the next 5 minutes. Okay, my dear children. Right. Note. Please observe this point, my dear children. In order to quicken this method, we can proceed as follows. Okay, my dear children. In the evaluation of definite integrals by substitution, we can follow these steps also. After performing steps 1 and 2, we have discussed 4 steps for evaluating definite integrals by substitution. So we have to perform that 2 steps, first 2 steps. There is no need of step 3. In the step 3, we resubstituted, isn't it or not, my children? After finding the integral, we rewrote the variables into original variable. Here the integral will be kept in the new variable itself, and the limits of the integral will accordingly be changed. Okay, my children, we have to change the limits of the integral. We no need to change the answer into original variable. Here we have to change the limits of the variable according to the new variable, so that we can perform last step. Understood this point, my children? To understand this evaluation of definite integral by substitution, let us take an example. Okay, my children? Right. To understand the evaluation of definite integral by substitution, here I am taking the question in the exercise 7.10 directly. Okay, my children? Right. Page number 340 in the textbook. Here I am taking the question number 1 in the exercise directly to understand this concept well. Okay, my children? See, evaluate integral 0 to 1 x by x square plus 1 dx using substitution. They will mention here directly using substitution. Okay, my children, sometimes they will not mention, just to evaluate integral 0 to 1 x by x square plus 1 dx. They will give like this also question. So there are two methods. Here first method, without changing the limits of integral according to new variable. Okay, my children, here we are using integration by substitution, isn't it or not, my children? So we have to change the function into new variable. So put here, let us assume that capital letter I is equal to integral 0 to 1 x by x square plus 1 dx. So in this method, first we find integral of this function separately. Okay, my children. So first to evaluate the integral of this function, I am substituting x square plus 1 is equal to x square plus 1 is equal to t. Okay, my children, x square plus 1 is equal to t. Then what we get by taking derivatives? What is the derivative? 2x into dx is equal to dt. Here I am writing the direct steps here. Derivative of this function is 2x. Derivative of 1 is 0 into dx is equal to derivative of t is 1 into dt, because dx by dt will get here. So I transformed dt to RHS. Okay, my children. So I wrote this step directly. Understood this step, my children? Right. This implies x dx is equal to 1 by 2 dt. Okay, my children. X dx is there, so we got 1 by 2 dt. Therefore, integral x by x square plus 1 dx. Please observe this step, my children. I did not take limits. First I am finding indefinite integral without taking the limits here. Okay, my children? Right. What you get the integral? X dx is there. So 1 by 2 is a numerical coefficient. I write outside dt by t, because t square plus 1 is considered as t. So 1 by t. Understood this step, my children? Right. That is equal to 1 by 2 into integral 1 by x dx. What is the value? Log mod t. Because integral 1 by x dx is equal to log mod x. Okay, my children, by using this known integral, we got this step 1 by 2 log mod t. Again, we have to convert this variable t into the original variable. What is the original variable? X. So from this equation, let us find x square is equal to t minus 1. This implies x is equal to square root of we have to convert to t value. T is equal to directly t value is x square plus 1. Sorry, x square plus 1. That is equal to 1 by 2 log mod x square plus 1. T value again we substituted, resubstituted. Here we got the answer in terms of t. Again we are rewriting this variable into original variable. Original variable is x. So 1 by 2 log mod x square plus 1. Here no need to write a constant of integration. Integration part is over. Actually in the indefinite integral we add constant of integration. But here no need to write a constant of integration because we are evaluating definite integrals. Okay, my children? Right. Therefore, I is equal to integral 0 to 1 x by x square plus 1 dx is equal to, here we got already indefinite integral value 1 by 2. So, 1 by 2 log mod x square plus 1. We got this answer. For this answer, we have to use limits, lower limit and upper limit. Lower limit is 0, upper limit is 1. Now, we are applying the limits. Here 1 by 2 is a numerical coefficient. We can write it outside. Log mod x square plus 1. For this function, we use we apply the limits, upper limit minus lower limit. Okay, my children. So 1 by 2 log mod 1 square plus 1, upper limit. I substituted x is equal to 1. So we get 1 square plus 1 minus log mod lower limit 0, 0 square plus 1. Understood this step, my children? In this function, in this answer, first we substituted upper limit, that is 1. Then we get log of mod 1 square plus 1 minus, we are substituting lower limit in this function, log mod 0 square plus 1. Okay, my children, understood this step? Right. This is equal to 1 by 2 into log 3, sorry, log 2. Yes or no, my children? 1 square plus 1, log 2. Minus here, what you get? Log 1. Log 1 value is 0. So, okay, log 1. Okay, my children, that is equal to 1 by 2 log 2. Okay, my children, this is the value definite integral of this given function 1 by 2 log 2. Log 1 value is 0. Okay, my children, understood this method? This is the first method. Without changing the limits, we wrote the same limits, we used the same limits. What you got finally? 1 by 2 log 2. This is the definite integral of given function in this method. Okay, my children, understood? Right. Now come to the second method. What is the second method? By changing the limits of the integral according to the new variable. Okay, my children, you can follow any method which is comfortable to you, which is convenient to you, which is easier to you. Okay, my children, there is no restriction. Okay, my children, right. See here, for the same question, we are following the second method. That I is equal to integral 0 to 1 x by x square plus 1 dx. Okay, my children, here also we are using the substitution. So put x square plus 1 is equal to t. This implies what you get, 2x dx is equal to dt. Here I am writing the direct steps, my children. So x dx is equal to 1 by 2 dt. In the previous method also we have done these steps. Okay, my children. Now we are changing the limits. Here lower limit is 0, upper limit is 1. But we are changing the limits. Lower limit. When x is equal to 0, then t is equal to, in this equation put x is equal to 0. What you get then? T is equal to 0 square plus 1. What you will get? 1. So lower limit is 1. The lower limit is 0 is changed to 1. Okay, my dear children, understood this step. Now upper limit, we are changing upper limit also. When x is equal to 1, when x is equal to 1, what is upper limit here? 1. When x is equal to 1, then t is equal to, in this equation, whatever the function we have taken as substitution in that equation, put x is equal to 1. Then t is equal to 1 square plus 1. What you get here? 2. Yes or no, my children? So now the new lower limit is 1 and the new upper limit is 2. Okay, my children, understood? Right. Therefore, I is equal to integral. We are not writing 0 to 1. Here 1 to 2. 1 to 2. Understood this step, my children? We are changing the limits of the integral. Here we are directly changing the limits of the integral. And here x dx is there. What is the value of x dx? 1 by 2 dt. So 1 by 2 is numerical coefficient. I wrote here by x square plus 1 means t. Understood this step, my children? Right. This is equal to 1 by 2 into integral 1 by x dx. What is the formula? Log mod t. Log mod t. Because integral 1 by x dx is equal to log mod x. Only the difference is in the previous method we have not changed the limits. We converted the final answer into the original variable and we applied the limits. But here in this method we are changing the limits also. Okay, my children. In this case, here no need to write this answer into the original variable. Okay, my dear children. Right. Limits 0 to 2. 1 to 2. Lower limit is 1 and upper limit is 2, not 0 to 1. Okay, my dear children. Limits were changed according to the new variable. Understood this step, my dear children? Right. That is equal to 1 by 2 into here numerical coefficient, then we can write it outside. Then we apply the upper limit minus lower limit. So log mod 2, upper limit, we substitute t is equal to 2 minus lower limit log mod 1. In the place of t, we write 1. Understood this step, my dear children? That is equal to 1 by 2 log 2. Because log 1 is equal to 0. So I am not writing the second term. Here also, in this method also, we get the same answer. Understood the difference between these two methods, my dear children? You can follow any method. Okay, my dear children? Right. Now come to the next question in the exercise. Evaluate integral 0 to pi by 2 square root of sine phi into cos power 5 phi d phi using substitution. Okay, my dear children, here also we have to evaluate this definite integral using the substitution method. Here I am following the second method, means I am changing the limits of the integral according to the new variable. Okay, my dear children? Right. Come to the solution part. Let I is equal to integral 0 to pi by 2 square root of sine phi into cos power phi d phi. Okay, my dear children? Right. Now, cos power phi can be written as here integral 0 to pi by 2 square root of sine phi into, I am writing this one as cos power 4 phi into cos phi d phi. Can we write this cos power 5 phi like this or not, my dear children? Cos power 4 phi into cos phi d phi. Yes. Now integral 0 to pi by 2 square root of sine phi. Again this can be written as cos square phi whole square into cos phi d phi. Can we write it or not, my children? Cos square whole square is equal to cos power 4 phi. So I am writing this cos power 4 phi as cos square phi whole square. Okay, my children, understood this step? Right. Integral 0 to pi by 2 square root of sine phi into, here I am converting this cos square phi in terms of sine square. How can you write 1 minus sine square phi whole square into cos phi d phi. Understood this step, my children? I wrote cos square theta is equal to 1 minus sine square theta or not? Yes or no? Yes. So I wrote cos square phi as 1 minus sine square phi. I wrote the remaining function as it is. Okay, my children? Right. Now we put sine phi is equal to t. Put sine phi is equal to t. Then what you get? Derivative of sine theta, cos theta. So cos phi into d phi is equal to, what is derivative of t? 1 into dt. Because d phi by dt we get, I am transforming this dt to RHS. Direct I wrote this step. Okay, my children, we got cos phi d phi value is equal to dt. And here I told you I am following the second method. Means I am changing the limits of the integral according to new variable. What is the new variable here? T is a new variable. Okay, my children, right. So lower limit when I phi, here the variable is phi, here the variable is t. So when phi is equal to 0, in this equation put to phi is equal to 0. So t is equal to sine 0. What will get? T is equal to sine 0. This implies t is equal to 0. Sine 0 value is 0. This is the lower limit of the new integral. Okay, my children, understood this step? Right. Now upper limit. When phi is equal to pi by 2, what is the upper limit here? Pi by 2. So when phi is equal to pi by 2, then t is equal to sine pi by 2. In this equation only, whatever the substitution taken the function, in that equation only we have to substitute phi is equal to pi by 2. Then t is equal to, what you get? Sine pi by 2. This implies t is equal to sine pi by 2 value is 1. Sine 90 degrees 1. Okay, my children. Now the new lower limit is 0. New upper limit is 1. Understood this point, my children? Right. Therefore, I is equal to integral 0 to 1. Not 0 to pi by 2. Ignore these old limits. We have to write the new limits according to the new variable. Okay, my children, understood this step? Right. Square root of sine phi is treated as t into 1 minus sine square theta, sine square phi, that means 1 minus t square whole square, cos phi d phi is equal to dt. We are substituting the values in this integral. We get this step. Okay, my children, integral 0 to pi by 2 is there, lower limit and upper limit. But here lower limit is 0, upper limit is 1. So we changed the limits of the integral. Next root sine phi is there. Sine phi is treated as t. So root t into, here 1 minus sine square phi is there. So 1 minus sine square phi means t square whole square into cos phi d phi is there. So cos phi d phi is dt. Understood this step, my children? Right. That is equal to integral 0 to 1. Root t can be written as t power 1 by 2. Yes or no, my children? Now we expand this binomial by using a minus b whole square. Then what you get? 1 minus a square plus minus 2ab minus 2t square plus b square. I wrote the expansion directly by using a minus b whole square. A minus b whole square is equal to a square minus 2ab plus b square, where a is equal to 1, b is equal to t square. I expanded this binomial using this algebraic identity. Then we get this expression. Understood this step, my children? Right. Here I wrote the last step again here. Okay, my children. Integral 0 to 1 t power 1 by 2 into 1 minus 2t square plus t power 4 dt. Okay, my children. Now let us use a distributive property here. T power 1 by 2 into 1. Integral 0 to 1. What will you get? T power 1 by 2 minus 2 into t power 1 by 2 into t square. What will you get? 5 by 2. 2 plus 1 by 2. What will you get? Directly I wrote here. 1 by 2 plus t power 1 by 2 plus t into t power 4. What will you get? 9 by 2. Yes or no, my children? 4 plus 1 by 2. We are adding the powers a power m into a power n. By using this laws of exponents, a power m into a power n is equal to a power m plus n. By using this laws of exponents, we wrote these three terms. Okay, my children, understood? Right. Now, for each and every term, let us find the integral separately. So, integral 0 to 1 t power 1 by 2 dt minus 2 into integral 0 to 1 t power 5 by 2 dt plus integral 0 to 1 t power 9 by 2 dt. Okay, my children, understood this step? I am finding the integral of each and every term separately. At the same time, I wrote here numerical coefficient before the integral sign. Now, if you observe, this is integral x power n dx. So, what do you get? T power 1 plus 1 by 2 by 1 plus 1 by 2. Lower limit is 0 and 1. Minus 2 into, it is also in the form of x power n. So, 5 by 2 plus 1 by 5 by 2 plus 1. Here also same. T power 9 by 2 plus 1 by 9 by 2 plus 1. 0 to 1. Limits. Because integral x power n dx is equal to x power n plus 1 by n plus 1. Okay, my children, by using this integral formula, we wrote these three steps, three terms. Okay, my children, right. Then what you get? T power 3 by 2. Here also 3 by 2. Then we get 2 by 3 into t power 3 by 2. Lower limit 0 to 1. Okay, my children, understood this one? Here what you will get? 5 by 2 plus 1. 7 by 2. So here also we get 7 by 2. So 2 by 7 into t power 7 by 2. 0 to 1 plus here what will get? 9 by 2 plus 1, 11 by 2. So 2 by 11, t power 11 by 2, 0 to 1. Understood these steps, my children? I wrote directly. By simplifying the numbers, I wrote directly here. Okay, my children? Right. 2 by 3 into. Now we apply the upper limit minus lower limit. So 1 power 3 by 2 minus 0 power 3 by 2. I substituted upper limit minus in the same function lower limit. Okay, my children? Right. Minus 4 by 7 into 1 power 7 by 2 minus 0 power 7 by 2. Understood this part, my children? right, plus 2 by 11, 1 power 11 by 2 minus 0 power 11 by 2. Okay, my children, understood these two terms, right? Now let us simplify. Integration part is also over. Upper limit minus lower limit part is also over. Now simplification part is left. What you get? 2 by 3 into here 1 minus 4 by 7 into here also we get to 1 only, plus 2 by 11 into here also we get 1. Now simplify these three numbers. 21, 231, LCM is 231, 231. Then what we get here? 154, 3, 77 times 77 to 154 minus 733 times 33 into 4. What you get? 132 plus 11 table 21 times 21 2 times 42. Okay, my children. By simplifying these three numbers in the numerator, what you will get? 64 by 231. This is the definite integral of the given function. Understood, my dear children? I hope you understood the evaluation of definite integrals by substitution. There are two methods. You can follow any method which is comfortable to you, which is convenient to you, which method is easier to you. Okay, my dear children, in the examination, no need to write two methods. Only one method is enough. Okay, my dear children, will you try the remaining questions in this exercise, my dear children? In this exercise, 6 more questions are there. Follow the same steps, same procedure. Okay, my dear children, will you do it? Will you try yourself the remaining questions in the exercise? If you have any doubts, ask your doubts and get your doubts clarified. Okay, my dear children, right.